Compute the integral of x squared times the square root of x cubed plus 5. X cubed plus 5 is inside the radical, so that's a good choice for u. If we let u equal x cubed plus 5, we then calculate du. The derivative of x cubed plus 5 is 3x squared. So du is 3x squared dx. In our integral, I see we have an x squared. I see we have dx, but we're missing the 3. So what we'll do is we'll multiply the integral by 3 and then divide by 3 to counterbalance that. We can now rewrite this as 1/3 the integral of 3x squared times the square root of x cubed plus 5 dx. Now let's replace everything we have here in terms of u. So x cubed plus 5, this is what we chose for u. And then 3x squared dx is what we calculated to be du. So plugging these in, we have 1/3. The integral of this part right here, the part that's underlined, is du. The part inside the radical is u. So this gives us 1/3 the integral of square root u du. To make this more conducive to integrating, let's get rid of this radical and rewrite this as a fractional power. So this is the same thing as 1/3 integral of u to the 1/2 du. Now we can use the formula sheet. This fits the pattern u to the n du, whose integral is u to the n plus 1 over n plus 1 plus c. So we're going to apply the power rule on this. The 1/3 that's outside the integral will just stay. We add 1 to the exponent, so we have u to the 3/2 over 3/2 plus c. And then we can simplify this. We can replace u with what we identified u to be in the first place. And we can also rewrite this fraction. So this gives us 1/3. Instead of dividing by 3/2, we'll multiply by the reciprocal. So multiply by 2/3. U, we're going to replace with x cubed plus 5. And we're going to keep the exponent of 3/2 plus c. We can go one more step and simplify by multiplying the fractions together. So this gives us 2/9 times x cubed plus 5 to the 3/2 plus c.